Okay, welcome back. It has been a while. It's been a crazy couple weeks, and so I've had to put this on the back burner, but I'm back now. However, as a result of having a break, I tried resuming this earlier and I had no idea what was going on with these pointers and stuff, so I had to get a quick refresh. I also asked it why exactly did it say use 2 pointers and keep walking inwards, because initially what I was trying to do with this function was something that I would do in my day-to-day job as like a TypeScript coder. Well, I don't write any code anymore, AI does, but normally I would just declare a new string because I've been trained against mutation and fill in that string. However, when I tried doing that, I realized I had to declare a new string and I'd have to allocate it memory with the same length as the incoming string. I don't know how to do that yet. I haven't learned those that stuff yet. So I'm going to do this the way that it's telling me to do it. And the key thing here is we are mutating the string that is currently at the address. So the original string here is hello. We're going to give it the pointer and we're going to mutate the memory at that address. Makes me feel dirty because I'm a functional programming enjoyer, but at the end of the day, no matter if you're using a functional programming language or model, it's going to compile down to C, it's going to compile down to assembly code, and it's going to be reallocating memory. It's going to be mutating memory at the end of the day. So I might as well learn how to do that. One thing I found that I'm going to do is put this pointer here on the character. I don't know why the pointer is like normally at the function name level, because to me, this is saying this is a function that returns a pointer to the character here. And it receives a pointer to a character when you get the string variable here. Okay, now let's pick up here. So we've declared string length is the length of this string, and I believe this takes the pointer and it keeps walking until it finds that end whatever rune it is, the /o that I've made a note of here. And so we do have an integer here, and we've created another pointer called end, which takes the string pointer. So that's the start of the pointer, sorry, the start of the string, the first letter, takes it to the string plus the string length minus 1, because we want to get rid of, we don't want to count that terminator there. So I think last time we left off, this is printing the correct last letter in that little section of memory that we have taken up with this string, right? So I'm going to rename this to right, because it's a pointer that is the right pointer, and we will be moving it, we will be changing it. So the pointer is going to move inwards, and we're going to use that to mutate our string as we go. So right here and right there, and instead of, yeah, let's just return that for now. So what are we going to do now is we have to create a left, I believe a left pointer as well. So character pointer to a character, this is going to be left, and right now it's going to take string. So that is the first letter. Okay, and then I believe I sort of had to ask it what it wants me to do, because I had no idea what the techniques it was trying to get me to arrive at. So I did have to ask it what to do. So what we're going to do here is a character. We're going to declare the character temp, which we're going to use as a holding space. Okay. So that we don't end up losing data. So this is like a third storage space. It's going to be, I believe, on the stack, so it's not going to be a pointer anywhere. this temp is going to live on the stack. It's going to get destroyed later on, I believe. And the temp, I believe it's okay. We're not going to initialize it. All right. So now we are going to write a loop. Is that right? We're going to write a loop. Okay, so the loop is, so that's a for loop. I guess, like, do we want to use an integer? No, let's do it. I think it's while. So while the left pointer is to the left of the right pointer. I don't know if that actually works completely. Like, does this less than sign denote that the left is to the left of the right? Anyway, I don't know. But as long as the left pointer is to the left of the right, then that means we still need to swap. So what we're going to do is we're going to save the character at the left into temp, right? So temp equals a dereferenced left. So that is taking the actual character. So left is a pointer and it's dereferencing it. These stars mean so many different things, no matter, like, depending on where they are. It's so frustrating. So we have saved the left letter into temp. We're now going to assign, we're going to write to the left address, which is what this star means here, which is not dereferencing, which is what that means, equals a dereferenced right. Okay? And then we're going to take the temp. We're going to write to the right address, whatever's in temp. We're going to not forget our semicolons. All right. Then we're going to return, what we're going to return is, I think, just string, because we are mutating the string. It's going to be the same length, and we're just returning the pointer to the first character there. So if I get this right, what I'm really not sure about is this less than thing. But anyway, let's try it. Character reverse string. Okay, so now that we've reversed it, we are going to print it again. So printf. So reversed string, and it's going to be percentage C, percentage S, was it? No, S. So that takes a pointer. Sorry, let me get the result here. So the result here is like result. I think it's like it's a pointer equals first thing. Character pointer result equals that. We're going to give it result, and then it's going to return that. So let's try to compile that. I have no idea if that is correct. GCC-WALL-W extra. I somehow remember that bit. And I believe it's output then input. So -O string reverser, and then it's string. Oops, I pressed tab. Reverser. Let's see if it picks it up. Nope. Let's see. Okay, sorry, so I'm in the wrong directory. Let's go to for, do that. Now let's run string reverser. Okay. so it's printed the start and the right. It hasn't, I don't know, it hasn't done this thing at least. Okay, so there's something wrong with my code. Okay, Mr. Tutor, what's wrong with my code? Here's the output. And it's literally just these lines. So we're doing this at least. Yep, we're stuck in an infinite loop. The two printf calls before the loop run, then that's why you know C. Okay. So you swap the characters at left and right, and then loop again with left and right at exactly the same addresses. Ah, we're not moving it. We're not moving it. Okay, the condition left. So it looks like my condition is correct. That's cool. So we're swapping the same two bits back and forth, and we are killing that CPU. All right. All right, cool. You can really get yourself into hot water with C, apparently. The pointers need to walk inwards each iteration. Right, I've created a condition and I've never actually incremented it, of course. So left moves, and then right minus minus, right? And so at some point it's going to exit this loop. Let's do it again. And there we go. It is actually reversing correctly there. Okay. One thing I want to make clear is my understanding of this. I need to understand this. Left and right are both pointers. So the operator less than implies that there is some sort of value on the pointers, and that left is somehow lesser than right. And I want to see what that means. I'm wondering if I should cut out these bits here where it's thinking, but I don't know. So it says exactly right, and your instinct is dead on. A pointer is a value. It's a memory address, yep, which is in practice a 64-bit unsigned integer. So the operator compares those integers. So it means that there is a logical sequence with these addresses. So the OS hands a program a contiguous block of memory, blah, 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 blah. Okay. The actual addresses will be different, but they will be consecutive because we've taken that bit of memory and sort of reserved it for this string. So therefore, left starts off as 0x1000 in this example, and right starts as 0x1005, and therefore this does have a left. When it's less than, it does actually compare those two properly. Okay. I understand that. The next thing to do is we are going to take in an input, and then we're going to reverse whatever the input is. So right now we are hard coding this as hello. Now we're going to take in an argument and then reverse whatever the person puts in. I'm going to add a new line there because it doesn't do that automatically. Okay, well, I'm looking forward to that in the next video. Thanks for watching. Please like and subscribe. Bye.